In this video, I'm going to show you how to use the His Ink Paper Airplane datasheet. So the first thing you're going to do is from the course page here, you're going to scroll down until you get to the final step. And so this is the video you're watching here, and you're going to go down here to the Paper Airplane Project datasheet, and it's a PDF download. So you'll just go ahead and click on that. And so if you're using Google Chrome, that will open up a page like this. And you can either print it right from your web browser, or you can save it on your computer. I'm going to go ahead and save it. Then you just type in a name to save it. I'll say Paper Plane Project. I'll save it to my desktop for now. Now if you're using Firefox, it'll be a very similar experience. You just go to the bottom of the page, click on the PDF download, and again that'll take you up into a PDF viewer from your web page, and you can go up here to the top to print it, or you can press this download icon here, and that's the same as saving it to your computer. So that'll open up that dialog box. You can either open it with your PDF viewer, or you can save it to your computer. And finally, if you're using Internet Explorer, you're going to just scroll down to the PDF download again, click on it, and then again that will open up a new tab, but you'll get a dialog box right away that will ask you what you want to do with it. And so again, you can open it with your PDF viewer, you can save it to your computer, or save as. Now if you just save it, that'll just keep the name it already has, or you can give it your own name by clicking Save As. So for now, we're just going to open it in our PDF viewer. So we'll click that. And it'll ask you if you trust the place that you're downloading from, and so we'll just say allow. Alright, so now we're in the PDF viewer. Alright, so now I'm just going to give you a quick overview of the data sheet here. Up in the top left corner, we see that we have a table, and this is going to be where you're going to record your results for each of your throws. And over to the right, you have a little box here that's for writing down the winners of your paper airplane contest. And then below the table, we have another little box with a formula for velocity, and then some references here for converting inches to centimeters or meters to centimeters if you need to do that. And then to the right, you have your directions on how to complete the project. And then down here we just have another table. This is just the same as the one on top. This is just so that you can do another test, because it's good in scientific projects to do things more than once to be sure that the results are consistent. And then you scroll down to the second page here, and you see that you have a couple of graphs here with an example filled in already. And this is just where you can visually record your data, so you can clearly see the winner and the differences. So we have a chart for time aloft, distance, and then finally velocity. Alright, so let's go ahead and walk through how you're going to fill this out. So first you go to the directions, and you see that the first step is to number all the planes. Now the reason this is important is because when you're doing experiments, it's much easier to record data when you can just look at a number and then you know exactly which row to put it in. Now you could write all the names in the rows, but the problem with that is it's a little more ambiguous. You don't quite know for sure. It's harder to tell the difference between the swallow plane and the eagle plane and all those other planes you'll be making. But if it has a big fat number on it, it's very easy to see which one it is. So after you've done that, you're going to pick the plane that you've numbered 1, and you're going to throw it, and you're going to record the time that it's in the air. So you could either count in your head or out loud, or if you have a stopwatch, even if you wanted to be really exact, you could do that. But once you have the time, once the plane hits the ground, you're going to stop the time, and then you're going to go over to your chart here, or your table, excuse me, and you're going to write the time in. So let's say that this one went for 8 seconds. So we'll write that in. And then next you're going to take your meter stick, or if you don't have a meter stick, you can use a yardstick or a ruler or whatever you need to. And in that case, you would have to convert them to meters, because meters is the scientific measurement. So you're going to measure how far it went in meters. So in this case, let's say that our plane went 18 meters. So now what you're going to do is you're going to look down here and you see this formula for calculating velocity, and you're going to calculate the velocity for that plane. So in our case, for plane number 1, we see that the distance was 18, so that's going to go on the top. And we're going to divide that by 8. And so when I do that, I get an answer of 2.25. So that is my velocity. So I'm going to write that in this column here, 2.25. And so now you're going to do that same routine for each of the remaining planes you have. We've provided you with 10 spots here, but if you want to try making your own, you certainly can. There's no limit. But the important thing is to record the time and the distance, then figure out the velocity. So fill out the entire chart. And then once you've done that, what we're going to do is go down here to the second page, and we're going to record our results on the graph. So we're going to start here with plane number 1. That's what these numbers are down here. And then up here, we see that this is the time chart. So these numbers going up here, those represent the time in seconds. And so our plane number 1, when we threw it, it went 8 seconds. So we'll go ahead and draw a line there, and then we'll just kind of sketch out a bar there. And then if you want, you can kind of fill it in. I'm not going to fill it in all the way because it's a little hard to do it on this computer program, but you can color that in if you like. And then so you see that will just give you a really easy comparison point to the other flights. So we see here in the sample, we can clearly see how much less time that was in the air than the other one. And so you go down to the distance, and it's the same thing as the time. You just start with, you find the number of the plane, and then now here we have to kind of guess a little bit, because it went 18 meters. but we don't see a number 18 on here. So what you have to do is just guess about where it would be. So probably be a little above the middle, so we'll say about right there. So we'll just mark that out and then just finish sketching out the bar there. And then again, you can color that in if you'd like. And then finally, we're going to come down here and we're going to calculate the velocity. And this is the same thing, you just add the number, start with number 1, and our velocity was 2.25, so again we know that is right between 2 and 2.5, so we'll go about at the halfway mark, and then just finish marking that in. And so now we have a clear visual representation of the different flights. And then once you complete it for all 10 flights, or however many number you do, then you'll have a very clear idea of which ones went the furthest, which ones stayed in the air the longest, and which ones were the fastest. So then once you have your results, what you're going to do is just go ahead and you can write down, we just gave you the top 3 spots here, just so you can see which ones were the fastest. So obviously I'm not going through all of these now, but let's just say that when you did it, the fastest was number 8, so you'd write that there, and then we'll say number 2, and then number 1. Now you can write in the names of the planes too if you want, but it's quicker just to write the numbers. And then the final step is you're just going to do the experiment again and just see if you get similar results. And so this table is exactly like the one above. So there you have it. Do this for each and every plane that you have built, and you will have used the scientific process for collecting, recording, and analyzing data. Go ahead and try the experiment several times to make sure your data is correct.